For a long time, we've thought of large language models as these incredibly smart brains, but ultimately brains that are totally trapped inside a digital box. Sure, they can write text, they can pump out code, but they can't actually do anything in the real world. Well, in this explainer, we're going to see how that's changing. Today, we're diving into exactly how we give AI the hands and feet it needs to interact with physical reality. Let's get into it.
Here's our roadmap for today. 1. Meet the AI agent. 2. What is tool calling? 3. Teaching AI with docstrings. 4. Building a light bot. And 5. Activating party mode.
Section 1. Meet the AI agent, bridging the gap between software and reality. So, it's a pretty fundamental question, right? Can an AI actually interact with the real physical world? I mean, if you ask a standard run-of-the-mill chatbot to just turn on your bedroom light, it'll spit out a text response apologizing that it can't do that. It literally lacks the physical means. But what if we could connect that raw intelligence to external systems? What if generating text was just step 1 in a whole chain of physical actions?
Think about a human instructor. Let's call him Qasim, which is an example right from our source material. Now, when Qasim teaches a class, he doesn't rely solely on his voice. He uses tools. He uses a microphone so the back row can hear him, a laptop to show his slides, maybe a car just to get to the classroom in the first place. And he intuitively knows exactly when to use each of those tools. An AI is actually exactly the same, but its tools are digital. Instead of a physical microphone, an AI's tools are things like email APIs, SQL databases, SMS services, and Internet of Things devices.
And that brings us to a really crucial definition. An agent is an AI system that autonomously decides which external tools to use to achieve a specific assigned goal. Notice that key word there, autonomously. We aren't just hard-coding a button that says send email. We're giving the AI a goal, handing it access to an email tool, and letting the AI itself decide if sending an email is the right move. That autonomy, that is exactly what separates an agent from your traditional chatbot.
Section 2. What is tool calling? The mechanics of AI decision-making. Tool calling, which by the way is often called function calling, is the specific technique used by a large language model to select, access, and execute those external services. This is a feature that was first pioneered by OpenAI, and as our source details, it is now incredibly powerful in models like Google's Gemini 1.5 Pro. It's the literal bridge. The AI generates a structured command, your developer code executes that command on the tool, and then it returns the result right back to the AI.
Guys, this is a complete paradigm shift in how we build software. Traditionally, if you wanted an app to do things, like query a database, send an SMS, post to social media, you had to manually build a specific user interface for every single one of those actions. You needed a login screen, a send message button, a post form. Everything was wired up to a specific backend route. But tool calling changes the whole game. The conversational UI replaces all of those buttons. You just type or say what you want, and the AI automatically routes your intent to the correct external function. It's wild.
Section 3. Teaching AI with docstrings. The shift to plain English.
You know, even just a year or so ago, connecting tools to an LLM was honestly a massive headache. You had to write out these incredibly complex JSON schemas or wrestle with difficult OpenAPI specifications just to let the AI know a tool even existed. It was highly technical. But the new way, it is almost shockingly simple. Using Python, developers now just use docstrings. That's the text you place between triple quotes to describe the tool in plain, natural English. You literally just type a sentence explaining what the function does.
Now, getting this docstring right is absolutely crucial. Think about it. If you give an AI a tool, like the ability to drive a car, but you don't explain how the steering wheel works, well, it's going to crash. Within those triple quotes, you have to provide 4 basic things: a clear description of what the function does, the required arguments it needs to run, the exact data types for those arguments, and what the function is going to return. If you lay these out clearly in plain English, the AI's internal logic will flawlessly figure out when and how to pull the trigger on it.
Section 4. Building a lightbot. Putting theory into practice. So let's look at how easy this actually is. Creating an agent bot is essentially just a straightforward 3-step process. First up, we define our Python functions. For our smart home light bot here, we define an enable function to flip the light on, a color function to change its hue, and a stop function to turn it off. Step 2, we simply grab the names of those functions and group them into a standard Python list. And finally, step 3, when we initialize our Gemini model, we just pass that list in as a parameter called tools. And just like that, boom, the AI knows its capabilities.
But there's a catch. We absolutely have to set boundaries using a system instruction. We have to give the agent a persona. We explicitly tell it, you are a helpful lighting system bot. You can turn lights on and off, and you can set the color. Do not perform any other tasks. Without this strict instruction, if a user playfully asks the light bot to order a pizza or calculate historical data, it might actually try to pull it off. This keeps the agent perfectly, strictly focused on its actual job.
And once this bot is up and running, the level of autonomy it displays is honestly incredible. In the source experiment we're looking at, the developer tells the bot to make this place purple. Now here is the fascinating part. The developer never actually programmed a dictionary of colors. No way. The AI autonomously understands the natural language, decides it needs to use that color tool we gave it, and internally calculates that the exact hex code for purple is #F00FF. Plus, based on those doc strings we wrote earlier, it knows it has to check if the light is actually turned on before it even tries to change the color. It manages all of that logic instantly.
Section 5. Activating Party Mode. The power of parallel execution.
All right, let's push this to the limit. We give our AI agent a very simple, highly ambiguous natural language prompt. Turn this place into a party. Notice we aren't giving it a strict list of commands. We're just giving it an abstract intent. And because the AI has access to a whole toolbox of smart room tools, it has to decide on its own how to interpret the concept of a party.
And this is exactly where parallel calling completely shines. The AI doesn't just execute one tool one after another, it triggers a massive sequence simultaneously. Autonomously, it decides a party needs 3 things to happen at the exact same time. It calls the disco ball tool and sets its Boolean value to true so it starts spinning. It calls the music tool and feeds it an integer value of 120 beats per minute for high energy sound, and it calls the lighting tool to instantly dim the room down to 30% brightness. A single English sentence just fired off 3 distinct programmatic functions across completely different APIs, flawlessly and entirely in parallel.
We have officially moved from chatbots that are trapped behind a glass screen to autonomous agents that can literally control our physical environment and software infrastructure. The friction of complex API connections, that's basically gone, replaced by simple English instructions. So, the question I want to leave you with today is this. Now that you know how to give AI hands and feet, what tools will you put in your next agent's toolbox? Thanks for joining me for this explainer. Keep experimenting and keep building.